Hello everyone. In this video, we'll look at how to solve problems using GDC. Here's our example. It says the time period t in seconds of completing one cycle of a pendulum of length L can be modeled by the following function over here. And we're to answer the following four questions. The first question is to find the domain and range. And this one, we can actually do it without calculator. The domain will just be the x value. In this case, it's our L value. Notice that inside the entire square root, we need to be greater than 0. So this is basically implying that our L needs to be greater than 0 or equal to 0. So that's our domain. And our range depends on whether our radical function has a positive or negative a value. In this case, our a value is 2 pi. So in this case, it's positive. You will realize that it's y, in this case, t greater than or equal to whatever the value at the end, the k value over here. In this case, it's 0, so it's t greater than or equal to 0. And that's it for our domain and range. Now, let's graph the function using our GDC. In this video, I'm going to show TI-84. So to graph a function, the first thing is we reach this button y equal. And then you will see if you have anything that previously exists, you can just hit the clear button over here to clear that. And let's check the graph button first. Sometimes you might have a window that was previously used and therefore it might be very off. In order for you to get back to the standard zoom window, you hit the zoom and then you go down to number 6, zoom standard, and then you click enter and you get back to the standard window view. Now let's go back to y equal, and then we punch in the function. In this case, our y is t already, so we don't have to type that. And we have 2 pi, square root, fraction is alpha f1, and then you hit enter. And then our L is our x over 9.8, and then we can graph that. In some cases, you will see a very nice curve over here. In some cases, you can't see that. The tip is usually to go to window and try to set your x min max and y min max. In this case, we're doing fine, but in case if you want to see a better picture over here, what you could do is you can refer to the domain and range that we wrote over here. That gives you a pretty good clue of what your window should be set as. So in this case, you could actually go ahead and set x minimum as 0 because our domain starts from 0. And our range also starts from 0, so you can also set that 0 as well. By doing that, you can see an even clearer graph over here. And that's it for the graphing part. If you want to find part C, the time period of completing one cycle of a pendulum with length 2 meters, this is basically asking you to plug in 2 meters into your L value. There are two ways to do that. The first thing is you exit the graphing feature over here by hitting clear, and then you go back here and do the calculation. By the way, if you are in this page over here, if you hit clear, you're going to clear the whole thing over here without exiting this display over here. If you want to exit this page over here, instead of clicking clear, that wipes everything out. You go to second and quit this blue button over here to go back to the calculation page. And here we go. What we can do is we can punch in 2 pi times square root and then fraction and then 2 divided by 9.8. Okay, our answer is 2.83 seconds. Okay, the second method is you can actually go down to the graph. Okay, so once you see this, given the fact that you already have the 2 x equal to 2 over here on your graph, because when you set your window, your min and max is 0 and 10, and your x value equal to 2, which is the value that you're supposed to plug in over here, is within the window. That means you're okay. Okay, so you go ahead and hit trace, and all you need to do is you press 2 as your x value, and then you press enter, and they'll give you the corresponding y value right away, which is exactly what we got before by punching everything into a calculator. Now finally, part D, the question could ask you to actually plug in the y value and to find an x value. So in this case, for example, they want you to find the length of a pendulum that will complete one cycle in 10 seconds. That means we will set t equals to 10 and then we will solve the equation, right? So this is basically like this. So you set t equals to 10 and then you need to solve for L. So this is our equation over here. Of course, again, you can go ahead and solve the equation by doing some calculation over here. At the end, you will do 10. First of all, you divide it by 2 pi. Be careful, when you're dividing by 2 pi, you need to divide by 2, bracket 2 pi over here. Okay, this will give you the right answer. If you do 10 divided by 2 pi over here, this calculator will read this as 10 divided by 2 first, which is 5, and then 5 multiplied by pi. Right? This will give you the answer of 5 pi, which is not what we want. We want this one over here, right? And then we want to square this one over here, and then we multiply by 9.8. So in this case, the answer will be 24. L is equal to 24.8, for example. You can also solve this graphically. So our second method is solving that graphically. We go to y equals first, and then we go down to our y2. On y2, we type the y value that we want to equate our equation to. So we type 10 in this case. And then we graph again. We realize that in this case, because of the window that we set, y equals 10 is at the top maximum over here. So we don't really see an intersection. That means we want to extend our window a little bit. It's better that we extend the x to something further. So we will probably extend our x to 30. But you can do it step by step and see. You can keep doing it until you see an intersection. And then our y maximum, because you see 10 is being at the top, right? So maybe you want to leave some space over here. So maybe 15 then. So here we go. So our graph looks like this. You will see a graph that we originally saw, and you will see another graph that is a flat line. This red graph represents the y equals to 10 graph over here. We want to find the intersection of the blue and the red. So how we do that is we go to second and calc. Okay, so the calc button, second trace, but that leads you to the blue calc button feature over here. You go down to number 5, intersect. And then here they will ask you 3 questions. The first question is, on your first curve, which is a blue curve, can you try to go as close to the intersecting point as possible? I think this is good enough. Even this is good enough, right? So you hit enter. They ask you the second question. It says, on your second curve, can you also do the same thing, approaching to the intersecting point as close as possible? This is actually good enough. And then you press enter. And then the third question they ask you to guess, which they ask you to go ahead and activate the calculation over here. So you hit enter. You do nothing over here by hitting enter. And then there you go. The intersection is x equals to 24.8, which is exactly the same as what we got. Y is equal to 10 because we want to set y equals to 10. But then this is what you get for your answer.